Hello everyone, I hope you're doing well. So in this video, we're going to discuss problems A to E and problem G1 of Codeforces Round 867, which was written for Division 3. So I was able to solve problem A to D and problem G1 during the contest. I was unable to solve problem E during the contest because there was some issue in my logic, a very small issue. But unfortunately, I couldn't solve it during the contest. So after the contest, I implemented the same problem or this and the same logic with a different way, and it worked. So anyways, this contest was pretty average for me, and I believe like the whole problem set was balanced. So let us quickly discuss the problems now. So the first problem is A, that is tube feed, right? So the problem statement says that there are some shows arranged in this particular manner. So this is show 1, show 2, show 3, show 4 like this, and each show has some time division associated with it, right? And this is the entertainment value of that particular show. Now our main character has t seconds in total, so we have to tell what is the index of the show that will provide us maximum entertainment, right? So while dealing with this, you have to take care, like you will start from show 1 and you will go up to show n, and to change a particular show, right, to go on to the next show, you need 1 second or 1 unit of time, right? So the total time required to watch any particular show would be the initial time required to reach that show plus the time duration of that particular show, right? So this is the idea. So this is the whole question. Now let me just discuss it with a sample test case so that you understand this particular thing better. Right. So for example, if we have n is equals to 5 and the value of time is 9, right? So 1, 5, 7, 6, 6. This is the time duration of the show, right? And this is the entertainment value of the show, that is 3, 4, 7, 1, 9. To reach this particular show, you need 0 seconds and the total time duration is 1 second. So it will take total 1 unit of time and the entertainment that you can get from it is 3. So if you talk about the second show, you will observe that you will need at least 1 unit of time to reach here and 5 units of time to watch this particular show. So the total time is 6 and the entertainment that you will get is 4. So since 6 is less than equals to 9, that is the maximum time that we can have. That is why we can consider this as an answer. Right. Now move on to the next show. For this particular show, the maximum the time taken to reach this particular show would be equals to 2. And the value is 7, the duration of the show is 7, so the total value would be 9 and it is still less than equals to the time that we have, so we can also consider this particular answer. So since the next entertainment value is small, let us not talk about it, let us directly talk about this particular value. So to reach this particular show, you will need 1, 2, 3 and 4 units of time, right? And the total time of this particular show or the total duration is 6. So the total value is 10, which is greater than 9. So we can definitely not consider this particular show. So the show that we could have considered as an answer and had the maximum entertainment value was at index 3. So this is index 1, 2 and 3, and hence 3 is the answer for our first test case. Right. So you can do it for all the values. Now there are many ways to check the total time. First way is to since this is index 0, this is index 1, this is index 2. So the total time at any index will be equals to I if you consider 0 based indexing, right? So all you have to do is I plus T of I, right? So this will give you the total time, right? If it is less than or equals to the time that we have, so let's say this is the maximum time that you can have, then you consider this value that we have and check whether it is greater than the already entertainment value that we have, right? So if the last entertainment value that we had was 4, now since 7 is greater than 4, then it is a better answer. So we update the index, right? So this is the whole idea of the statement problem. Now I'm just going to show you the solution directly from here. So earlier I used to show you more refined solution from Sublime Text, but now I'll be sharing the solution directly from my accepted submission. The reason is, if there is a case when my problem passes the pre-tests but it fails the later test, so at least in that particular case you will be able to see that I only made a solution for that particular problem when my own solution was accepted, right? So this should not be the case that my own solution was not accepted and I made a review, right? This should never happen. So that is why I'm just going to show you my accepted solution from here on, right? So let me just open this in a new link. So this is what we have, right? Now what I've done is I've initialized two vectors A and B. If I can just zoom it a little bit, so you can see that I've initialized two vectors, vector in A and B. So this is my way of writing it, and I've taken input and. So I've initialized my maximum variable with -1, right, and my answer variable. So you could have also used directly the I value. I have maintained the variable dx. So if dx plus a of I is less than equals to t, that means we can afford to watch this particular show. And then I check if b of I, that is the entertainment value of that particular show, is greater than the maximum value that we have. Then I update the maximum. Then I update this particular value of maximum, right? And I update my answer with I plus 1, right? Now after this is done, I just increment my value of dx, and for each value or for each index I'll update the same. Now at the end I can just check if the maximum value is still -1, that means there was not even a single show I could afford to watch, and in that particular case I'll print -1, otherwise I print my answer value, right? So this would be the solution for the first problem. Now moving on to the second problem. So let me just close this tab. Now for the second problem, what we have is we have an array of integers. So the problem statement says that we have to maximize the beauty of the array. So the beauty of the array is defined as, like, if there are some integers 3, 5, 7, 4, then the adjacent elements, we have to take the product of the adjacent elements. So 3, 5, 5, 7, 7, 4, and the maximum among these values is the beauty of the array, right? So we have been given an input array. We have to find maximum beauty of the array, and we can arrange the elements in any possible order, right? So this problem is pretty straightforward. So what do we have to do is, for example, if you have some elements, let's say A, B, C and D, I'm just telling you the idea of the problem. So for example, you want to maximize the product of two adjacent elements, right? So one possible answer is to take the greatest two elements. So for example, 1, 2, 3 and 4 were present. So I can definitely take 4 into 3. So right, this would be my possible answer. Now the other possible answer is I can take the product of the minimum two elements. So let's say -10 and -20 was there. So their product will be 200, right? So these are the only two cases that can yield a better answer than any other values, because the maximum two values will yield the greatest product, and the minimum two values will also yield the greatest product, because their minus and minus are going to cancel each other. Now you might be wondering what happens if there is only one negative integer and it is like this, right? So we don't need to worry about it. We can just calculate the multiplication here, and it will be -20, and this will be 6, right? So we can just take the maximum of these two values. We don't need to worry about it. We're just going to take the maximum of these two values, right? So this would be the solution of this particular problem. Now again, like this particular part where we need to find the minimum two values and the maximum two values, for this you can sort the array. You can sort the whole array, and the starting two values will be the minimum two and the ending two values will be the maximum two, right? So let us just have a look at the code now for this particular problem. So this is the code. Now what you have done is I have taken a vector of size n, and I have taken input in it, and I just sort the vector, and I initialize my answer with v of 0 into v of 1, and my answer 2 with v of n minus 1 into v of n minus 2, right? And I can just print the maximum of answer 1 comma answer 2, right? So this would be the solution of the second problem. Now let us move on to the third problem. So this particular problem says that we have been given, so I'm just going to summarize this whole problem for you. So this particular problem, I believe, was more of just observing a pattern. So you have to observe this pattern, and basically what you have to do is, for any n value, these are the figures. For example, this is for n is equals to 4, this is for n is equals to 5, this is for n is equals to 6. Now you have to count the total length of these brown lines, right? So I'm just going to show you with an example, and you will have a clear-cut idea of how you can solve this problem. And obviously, in problems like these, there are multiple ways to solve this problem, and I'm just going to share with you what I did during the contest, right? So for example, this is of length 1, this is of length 3, this is of length 5 and this is of length 6, right? Now if you look in this particular direction, this is of length 2, this is of length 4, this is of length 6 again, right? Now again if you try to do something else, this is 1, this is 3, and again this is 2, this is 4, right? Now I'll help you observe some pattern here. Now all the 4 corners would obviously be 6 length, right? So this is 1 length, this is 2 length, right? This is 3 length, this is 4 length, and this is 5 length. So what is the total value? Like if you carefully observe here, the total value, like I have marked this one, I have marked this one, I have marked this one, and this one, and this one, right? So the total value is 1 plus 2 plus 3 plus 4 plus 5. Now let me just mark some other values. So this one is 1, this one is 2, this one is 3, and this one is 4. So again, let me just add all these values. So this is 1 plus 2 plus 3 plus 4, right? Now let me just take the 4 corners. This is 6, this is 6, this is 6, and this is 6. So it is actually 4 into 6, 6 into 4, or whatever you can write, right? Now the only thing remaining is this particular line which we have not counted, right? So let me just include it separately, and that is 1. So you see, like we just have kind of formed a pattern thing in this particular case, and what we have done is we have taken the sum of integers from 1 to n minus 1. Then we have taken the sum of integers from 1 to n minus 2, 1 to n minus 2. Then we have added 6 n into 4, and then we have added 1. So this would be the final formula that we are going to use, right? The final formula is summation of I starting from 1 to n minus 1, then plus summation of I starting from 1 to n minus 2, that is I, plus n into 4 plus 1. This would be my final answer, right? So you just have to observe this particular pattern in the given figure, and if you were able to observe this pattern, then you would have definitely formed your answer. So let me just show you the code for this particular question now. There's nothing else to discuss in this particular question. It's just observation, and I don't think that there is any other way to solve this particular problem rather than observing. Now you might implement the same thing in a different way, like I've explained you of one way of observing this particular pattern. You might also observe some other pattern, and that is totally correct. It's just that you only have to observe the pattern here. So let me just show you the code now for this particular problem. So what I've done is I've taken integer n as input. So I've taken 4 into n, right? So this is summation till n minus 1 into n by 2, and this value is summation till n minus 2 into n minus 1 by 2, and at the end I'll just add to my answer and I'll print it. So this would be the solution for the third problem. Now moving on to the fourth problem. Again, I would say, like, if you were able to observe the pattern in this question, like how you can form your answer, you would have been able to solve this particular problem. So let me just show you with an example test case what this problem wants to say. So let me just take this particular value. So let's say we have 6, 5, 2, 3, 4, 1. So I don't remember the exact term. They called it a super-permutation, right? So they're calling it a super-permutation. Our goal is to print a super-permutation of size n. Right, our goal is to print a super-permutation of size n, and this is a super-permutation of size 6. Now, how is it actually a super-permutation? So what we have to do is, for any index I, we have to take the summation of I starting from 1. Let's say this is j. All the elements aj starting j starting from 1 to I, right? So for any index I, we have to take the sum of all the values starting from 1 to that particular index, and then we have to take its mod with n. So for example, this particular value is 6. So the sum is actually 6 only. And when we take 6 mod 6, it is going to be 0. Right. Now we have to add 1 to it. So let me just write it here also. Right. So here we have got 1. Now if I add 6 plus 5, now 6 plus 5 is equals to 11. And if I do 11 mod 6, it is going to be 5. Right. So if I do 5 plus 1, this would be 6 here. Now if I add 11 plus 2, that would be 13, and 13 mod 6 would be 1, and if I write it here, it would be 2. So I'm just adding 1 to all those values. So now I have 13 plus 3 is 16, and 16 mod 6 is I guess 4, right? So 4 plus 1 and 5 will be here. So 16 plus 4 is 20, 20 mod 6 is 2, so I'll add 2 here, and 2 plus 1 is 3. So 20 plus 1 is 21, and 21 mod 6 will be 3. So I'm going to write 4 here. So you see, whenever I calculate these particular values, what I've done is the final array that I have formed is also a permutation of size n. Right. So this particular permutation is only a super permutation if when we like apply these steps, what we have done just now. If you apply these steps, the final thing should also be a permutation. Right. So what we have to do is, you will observe that in every case, if we fix the first two elements as 6 and 5, then what we have to do is at each steps we are adding 5 to our current value. So since 5 was here, I have added 5 to my current value. You see that the sum of these two values is 5. Now again the sum of these two values is 5 again. So what we are essentially doing is, if our value is n, we fix the first two characters n and n minus 1, and then we are taking two values which has the total sum n minus 1. Then we are again taking two values which has the total sum n minus 1. So what is the base idea of doing this? So for example, initially, let's say we are not considering this particular case now. I'm just showing you an example what happens when we do this. So initially, let's say the value was 6. So 6 mod 6 would be 0. Now if I add 5 to it, then the value would be 11, and 11 mod 5 would be 5. 11 mod 6 would be 5. Now if I add 5 to it, 11 plus 5 is 16, and 16 mod 16 mod 6 would be 4. Now if I add 5 to it, this would be 21, and 21 mod 6 would be 3. Right. So you see, we are getting one by one, we are getting all the values, 5, then 4, then 3, then we will get 2, and so on. Right. So this way we are getting some values in some serial order. Right. So this is like one viable way of solving the problem. That what I want to make is, I want to find a pair such that its sum is equals to n minus 1. Now since we are already finding pair, you must have observed that if the value of n is odd, then the answer would be straight away minus 1, because we cannot form our answer in that particular case. Otherwise we will also always be able to form our answer, right, when we want to make the pairs. Now the next question is, how do we decide which values come here? Right. So like this is also just observation. What I did was, like I took 6 and 5 here. So the next value that I wanted was, so in this particular case, what I observed was, like 2 was coming here and 4 was coming here. If you take a bigger example, then 6 will come at the next position. So like what I decided to do was, to continue this pattern, I observed that you need to put the even integers here. Right. So initially it was 2, then it would be 4, then it would be 6, and so on. So once I have fixed 6 and 5, so 6 and 5 is fixed. Let me just write it. 6 and 5 is fixed. Now I would want to put the first even number here, that is 2. So I also want to make sure that the sum of these two numbers is equals to 5. So I can only put 3 here. Then the next number I would want to put here is 4, and I also want to make sure that the sum of these two numbers is 5. So I can just put 1 here. Right. So this would be the pattern that I will be following. I place the greatest two integers n minus 1 here. Then I start placing 2, 4, 6, and so on. And like beside these elements, what I'll just put is, I'll put n minus 1, minus 2, n minus 1, minus 4, n minus 1, minus 6. And this will work for all cases. Right. And also I wanted to mention one more thing, that we discussed that whenever n is odd, the answer will be minus 1. There is an exception to this particular case when n is equals to exactly 1. Right. So you will have to deal with this particular case separately. Now let us have a look at the code of this particular problem. So the problem statement that the code we have here is like this. So the code is also very simple. It is just what I have explained till now, where whenever n is equals to 1, what we just do is we just print 1 and that would be our answer. Otherwise, if n is odd, I just print -1. Otherwise, when n is even, I print n and n minus 1 first, and then I run a loop from 2 till less than n, and I am incrementing the value of I by 2 every time. So I am printing I and n minus I minus 1, right? So this would be the final solution of this particular problem. Now moving on to this particular problem, which is E making anti-palindromes. I made many long submissions on this particular problem, and my approach in which I was calculating the final answer didn't work correct. So I changed the approach and submitted it after the contest. So let us discuss what can be done in this particular problem. The problem statement is very straightforward. It says that a string is called anti-palindrome if for every index I, s of I is not equal to s of n minus I plus 1, right? So let me just show you with an example. So we are going to discuss the third test case here. So third test case is T A R R R A T A. Right. So like the normal condition for a palindrome is that these two characters should match, right? Again, these two characters should match. These two characters should match. These two characters should match, right? So I believe like I have missed some values. So I got it. This matching should be till here, and this will be till here, and these two will be together, right? So the normal condition for a simple palindrome is that the pairs that I have made should be equal, right? Now for an anti-palindrome is that these two characters should be necessarily different, like they have to be different, and we have to tell the minimum number of steps that we need to make the given input string to be an anti-palindrome. So you see that the first pair, that is T and A, is already different. That is good enough. Now these two A's are similar. Now we need to do something about it. Again, this particular A and this particular T are different, so no problem. This particular R and this particular R are same. So what we can essentially do is I'll just write TAA R, and then I replace some strings. So I can write A here, then again A here, then R here, and then A here. T was also here, right? So what I've done is I've replaced this particular A, right? So I've changed this particular A with this particular R. So once I do this, what happens is now you will see that all of them are different. So this is different. This particular string is different. These two are different. A and R are different. T and A is different, right? And what I needed was I just needed one swap, right? So one swap. So the final answer or the total number of operations will be 1 itself, right? So I can make any number of swaps, and I just have to find out whether it is possible or not. So the very first thing that you would have observed is if the size of the string is odd, if n and 1, that means you can never form your answer, because this value will be same to itself no matter what you do, no matter what swaps you make. The middle element will always be equals to itself, right? So this is not something we can change. Now one important thing that you have to observe is, for example, if the string is something like this, right? So let me just divide it into two halves. Now these two characters are same, and I would want to swap these two values. Now where do I with which index I swap this particular value? So it is always optimal to swap it with the right half itself, or I just swap the values in the left half only, or I just swap the values in the right half only. Why? You will observe that if I observe it with this particular character C, then B and C will be together and A and B will be together, right? But let me just if this was the original string and I swap this with this particular string, then you will see B will come here, B will come here, and this would be A and this would be C. Again, B and A and B and C are together, right? So no matter if you just swap it a particular character in its own half, it will be equivalent to swapping a particular character in the other half, right? It will always be like this, Now in this particular case, B and C and A and B were together. Again, B and C and A and B were together. So no matter in which half you swap, you would always get the same answer. So it is always better to swap the values in its own half, right? So this is the next observation. Now, how do we optimally swap those values? Now let us discuss one more case where the answer is never possible. Since you have observed that it is always optimal to swap the value within its own half, right? It is always optimal. Now, for example, let us assume a case where the frequency of any character is greater than n by 2, right? So if the frequency of any character is greater than n by 2, so for example, n is equals to 4 and n by 2 is 2. So what I have done is I have assigned the complete right half to B, right? Now if there was a C here, then it would have been no problem. But again, if I write a B here, then these two are matching and I don't even have a place to escape, right? So these two characters are matching and I don't even have a place to escape because I cannot swap it with any other character, because all the other characters in the same half are already B. No matter with which character I swap, the value will always be the same. So again, I can write it like this, right? So C is equals to 4 here. The frequency of C is 4 and n by 2 is 3, right? Since 4 is greater than 3, then the answer will be -1 here. So I'm just assuming a particular case when the frequency is greater than n by 2, where I assign all the values to the right half. Now I assign the remaining values to the left half, and like there will be at least one position where these two match, and when I try to swap those values, I'll have no place to escape, right? So in this particular case also, the answer will be -1. Now let us discuss what happens when we have found the answer, right? We already know now that the answer will not be -1 and there will definitely exist an answer, right? So again, let us say like we have some frequencies. For example, I want to change A, I want to change B, and I want to change C, right? So let us say there were 3 occurrences of A, 2 occurrences of B, and 5 occurrences of C, right? So let me just sort it once. Now what I can do is I want to change 3 occurrences of A, 2 occurrences of B, and 5 occurrences of C. It is always optimal to do them in pair, right? Since I can always swap these positions among themselves, it will be optimal to do it in pair, obviously. So what I can do is I can mark these two as pairs, right? And I can process them together. So once I process them together, this will be 1, this will be 3, and this will be 4, right? I have used one pair among them, right? So if A was someone here and C was somewhere here, I have swapped their positions and I have taken C here and I have taken A here. Now both of them have satisfied their individual conditions and the number of swaps was 1. So I'll just increment my answer, right? Now I can just like simulate this whole process where I'm just taking the first element and I'm taking the last element and I'm decrementing both of their values and I'm just again inserting them into the same data structure. I can simulate the whole process. The simple reason being the total sum of all these values, will be at max n by 2. Since n is 10 raised to the power 5 here, approximately 10 raised to the power 5, so I can easily simulate all this process because the sum of all these values is n by 2 at max, right? So if I want to simulate it, if for example if I use a data structure like a multiset, so if I use multiset, so the total time complexity would be n by 2 log n and let's say 2 multiplied by 2, just because like in each operation what you would be doing is you would be performing 2 operations, taking one element from the beginning, one element from the ending, right? So it is approximately n log n, right? The only reason we are able to simulate the whole process is because the total sum of all the values will be 10 raised to the power 5 by 2, and if you just decrement all those values one by one, we are easily going to use n operations or 10 raised to the power 5 operations, and each operation takes log n time approximately, so it would be n log n. So the whole idea is to store it in a multi-set kind of data structure and take the first value, take the last value, decrement both of them by 1 and increment my answer, right? And push them again to the queue, push them again to the multi-set if they are non-zero, right? So this would be the whole idea. Now at the end what you can also do is when there is only a single element remaining, that means you will have to find some other place for it and it cannot be solved in a pair. So the last element remaining, let's say it was some element 2, so I'll add this particular value 2 to my answer because I cannot form it with any other pair and I have to directly implement. Now let me just show you the code for this particular problem. So this is the problem. So you see, like I've commented a lot of part. This was my previous approach that I was using. So what I've done is, if n is odd, I can just directly return -1 from here. Otherwise, I create a frequency array and I increment the frequency of all the characters. Right. Now, if the frequency of any of the characters is greater than n by 2, then I just print -1. Right. Now I initialize all the values with 0 again, and I just traverse through the first half of the array. And if I see whether like there is a place where these two characters are similar, the character at ith position and the character at n minus I minus 1th position, if they are same, that means I have to change its position somehow. I'll increment that particular value. That if the character A is matching, I have to like change the position of one more A. Right. Now I initialize my answer with 0. Now what I do is I just create a multiset, and if the current value is non-zero, I just insert it into my multiset. While the size of the set is greater than 0, I just take the first element, I just take the last element. Since the ending pointer points to one location after the ending position, I just decrement my ending pointer. I just take two variables x and y, and I just take the value of first element, last element, and I just decrement it by 1. Right, both of the values. Now I just erase the initial pointers that I have got from the multiset, and if the value of x is positive or greater than 0, I just insert again x into my multiset, and if the value of y is greater than 0, again I insert it into my multiset. And since these were processed in a pair, my answer will increment by 1. Now if the size of multiset is greater than 0, that means there is one element remaining into the multiset. I'll just add that particular value to my answer, and I'll print my final answer. So this would be the solution for this particular problem. Now moving on to the last problem of today's discussion, that is G1. So this is the easy version of the problem, and this is one property that you need to know, and you'll be able to solve this problem easily. Right. So what I've done is I've created so this particular problem says that we have to find the triplet number of triplets I, j and k, and like these should be pairwise distinct. So what we essentially have to do is the value of if we take the first element as ai and multiply it by b, it should be equals to aj, and if we multiply aj by b, it should be equals to ak. Right. So we have to find the number of triplets I, j and k such that this particular condition is satisfied. So let me just show you an example what is actually happening here. So if you have three elements a1, a2 and a3. So a2 is actually obtained by multiplying a1 by b, and a3 is actually obtained by a2 by b. Right. So the very first observation that you need to know is, for a2 to exist, b should be a divisor of a3. I repeat it again, for a2 to exist, b should be a divisor of a3. Only then you will be able to find a2, like when you divide a3 by b, you will be able to find 2. Similarly, for a1 to exist, b should be a divisor of a2. So when you do a2 by b, you should be able to find a1. For all the three to exist together, you need to do a3 by b is equals to a2, and a2 is itself equals to a1 into b. So a3 should be divisible by b square, and then only you will be able to find a1. Right. So for all three of them to exist together, there should be a value b such that b square is also a divisor of a3. Right. So this is the first and foremost necessary condition for all a1, a2, a3 to exist together in a triplet. Now how do we find this particular value of b? So since the very important condition that was mentioned in the question was that all the values are up to 10 to the power 6, we can implement an n root n approach. So for the first n will be used to traverse the whole array, and the second root n will be used to find all the factors of every element. So ai is up to 10 to the power 6, so we can easily take root n time to find the factors of any particular element. The next question is, for how long, like for how much value should we need to check the value of b? So b would be like we do the primality test, it is similar to it. B will be only up to square root of a of I. Right. Why? Because when we do b square, if b is equals to square root of a of I, then b square would be equals to a of I. If we take any other value greater than b is square root of a of I, then it will be greater, the whole square would be greater than a of I, right? So if I do b plus 1 whole square, this value will be greater than a of I, right? So we only need to take value till square root of a of I. So what we essentially have to do is, for all values starting from 2 till less than square root of less than equals to square root of a of I, we need to check whether if we divide ai by b square, it is divisible by it or not, right? If it is divisible, that means all the values of a1, a2, a3 are possible. Now, since we need to find the number of pairs I, j and k, till now we have just found that a1, a2, a3 can be valid values, right? Now, if you want to find the number of pairs, we need to know the frequency, how many times a1 is present, how many times a2 is present, and how many times a3 is present. We need to know their frequencies, right? So the total answer or the final answer that these three will contribute is frequency of a1 into frequency of a2 into frequency of a3, right? Why? Because if there are two values from here, three values from here, this is a1, a2 and a3, and let's say there is one value from here. You can choose any two values, like one of the two values, you can choose one of the three values and one value here. So the total possible ways would be 2 into 3 into 1, right? So this will be 6 in this particular case. Now we have considered all the cases where the value of b was greater than 1. What happens when b is equals to 1? When b is equals to 1, all a1, a2, a3 would be the same value equals to ai. So in this case, what we can do is, for example, we have 6 occurrences of ai, right? This is 6, right? So we have 6 occurrences of ai is here, ai is here, ai, ai, ai and ai, right? So the total number of ways you can select the indexes are, so the first value I can be one of the 6 places, the second value j can be one of the 5 places, the third value k can be one of the 4 places remaining. So it is n into n minus 1 into n minus 2 in case you consider the value of b to be 1. In all other cases, when we consider the value of b to be greater than 1, we have to add these three values, that is frequency of a multiplied by frequency of b multiplied by the frequency of c, right? So this would be the final solution to this particular problem. Now let me just quickly show you the code. So this very one important thing I would like to share with you all also. So what happened was, I have created a map here. If you had observed, then I had one TLE submission in the same problem, and that was because I had taken a vector here, and vectors should not be taken because the size of the vector that I was taking was 10 raised to power 6. And if you create a vector of size 10 raised to power 6 for all the test cases, it would give TLE. So it was better to take a map here. Now what I have done is, I have taken number vector v and I have taken input 10. So I have sorted it, but it was not actually required here. You can also skip this part. But what I have done essentially is, I have created a set of numbers, right? So this indicates that these are the numbers present in my initial vector, right? Now what I do is, I just increment the frequency of each element and I just insert it into my numbers vector. Now I just traverse through all the values in the numbers set. So it was actually a set. So for each of the values, what I am doing is, I am just trying to find the value or the value of b starting from 2 till root of number. If number is divisible by b square, so this is essentially b, the value of b. If it is divisible by b square or I square, that means I have found three values a, b and c. So a will be equals to number itself, b will be equals to a divided by I, and c will be equals to b divided by I, right? So you can also write it as a by I and a by I square. So it is the same thing. Now we have to add this particular value to our answer, and that would be f of a into f of b into f of c, right? We have to add these particular values. So if the frequency of number is greater than 2, if that means the current element has at least a frequency of 3, so I can also take the values among themselves, and that the value that they will contribute is frequency of the number itself multiplied by frequency of number minus 1 multiplied by frequency of number minus 2. So this would be added to my answer. So after all this is done, I can just print my final answer, and this would be the solution for the last problem of this particular discussion, that was problem G1, magic triplets. So this was all about today's problem discussion. I hope you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe later if you don't find the videos interesting. So keep share this channel with your friends. Until the next video drops, keep coding. Stay safe. Bye bye.